Hey, welcome back. We'll look at graph of trigonometric functions. As before now, and now we're going to look at this. The graph is this table of special angle. Yes, we did this as the table. Okay, look at the table of special angle. So it will help us to sketch the 6 trig functions. So let's look at the first one. So the first one is sine. Yes, I had to use an app so that it will be very neat. So if you notice, the graph is always like this. Graph of y equal to sine x is always like that. So let's label so that so we'll see that the maximum, if you say from the table, the graph is always between -1. The minimum is -1 and the maximum is 1. So just know that the graph of sine is between 1 and -1. Very important. Because we're going to solve this. We're going to solve a question and that is 2. It's a simple version after the graphs. So you should know that the minimum is -1, so to alternate between -1. So that's the maximum. So what gave us that maximum? 1, which is 90. It's 90 degrees that gave us 1. While the minimum is 270. So here the value, the x value is 270 degrees. Y here is 90 degrees. So you can see 0, sine 0 is always 0. So that you see, so here is the point 0. So y here, sine 1/8 is also 0. Y 3/6 is also 0. So these are the most important points on this graph. This 1, 2, 3, 4, 5. So we've sketched the graph. So the graph is always like this. So let's look at cosine. So using that same table, you see that the maximum, the graph of cosine is alternating between -1 and 1. So it's between -1 and 1. Check. You see maximum is 1, minimum is -1. So if we sketch the graph, so the maximum here, cos 0 is always 1. So here is 0. From the table, you can see that y cos 90 is 0. So here should be 0. Also 270, 0. As you can see. And 360 is 1. So here should be 360. If you trace them. So y here is 1/8. 1/8 is -1. So it's here is -1. 6. So these are the most important points on this graph. So we'll sketch that. So coming to the next one, which is tan. So see the graph of tan. If you notice, there is a discontinuity in some places. Yes. So if you could remember, tan 90 and 270, they are undefined. Do you remember? Yes. So, and in undefined in graph is called a vertical asymptote. Yes. It's not defined, so there will be gap there. So if I put this line is called a vertical asymptote. So there will be a vertical asymptote at 90 degrees. and use 17. So we call this vertical asymptotes. So y here, if you could remember, 0 times 0 is 0. So here is 0. That's here. And 0 is 0. Also here, see that 1/8 and 1/8 is still 0. And 3/6 is 0. So tan has no maximum and minimum. As you can see, it can increase to any point. So the major point we are going to note here is the where it is not defined, which is the vertical asymptotes. So that's the graph of tan. So let's now move to the other, because from the table you have only 3. Let's use the knowledge of these 3 to plot the other ones. Yes. So how do you plot, especially sec and cosec? So once I've plotted the graph of tan, once I've plotted the graph of sine and cos, we can plot the graph of sec and cosec. Yes. So how do you do it? Let me just sketch before we move to the actual graph. Let's just sketch. So remember that the graph of sine, just sketch. We'll use that later. If you sketch the graph of sine, it's always this way. Y here is minus, this is minus 1, sorry, this is 1, this is minus 1, and this is 3, this is 90, that's 90, here is 90, Y here is 270, this is 0, 180, and 360. So, remember the values from the table, since cosec is the reciprocal of sine. And there are some places where sine is 0, sine of the angle is 0. So there will be a vertical asymptote at 1/8 because 1 over 0 is undefined. So anything over 0. So there will be a vertical asymptote at 0, 180, and 360. Yes. So if we now draw the vertical asymptotes here, and here, okay, this is already nice. So since we are talking about reciprocal, and flip this the other way around. So the resulting graph, remember this graph, this one is y equal to sine. So the red one is now cosec, y equal to cosec x, yes. So that's how we sketch the graph of cosec. So once you've drawn the graph of sine, you now get your vertical asymptotes. Remember, the green line is the vertical where it's not defined. That's where division by 0 occurs. Asymptotes. So once you get it, the other one, the resulting graph, by flipping the other one, this one is concave down, make it concave up. The same thing the other way around. So that's the graph of cosec. So let's make it neat. You see, so here is 0, this is 1/8, where it's not defined, and this is 3/6. Y here, the maximum, that's the minimum here, this is 270, cos at -1. Y here, right? So this one. So that's the graph. This is the vertical asymptotes. That's the graph of cosec. So that same logic, we can use it for sec. Yes, since we know that the graph of sec cos is like this. It's always like this. So where here is the maximum 1, y here is minimum -1. And it occurs where? It occurs at 90, 0, here, 0. So the 0 is 1. So this is 360, this is 270, this is 180. So the same way, if we now get our 70, so if we draw our vertical asymptotes there, so we now flip the graph the other way around. So the same way, almost the same, flipping it. See the other way, why this is. So why this is. So since this one, the sky blue, this is y plot plus. The red one is now sec. The red graph is now y plot to sec. So that's how we sketch the graph of sec using cosine. So let's now use let's use NECO. You can see what it looks like. Like I've said before, this is 1, that's -1. And the vertical asymptote occurs at 90. Was at 90 and 270. So here is 180. That's where is negative. So why this is 360? So each time you want to plot once you were able to plot the graph of sine, you can get the graph of y for cos. Again, tan, the graph is this. So meaning, where is 0? So for cos now, the vertical asymptote to occur. Okay, let me just sketch before. So let's sketch the way we sketched. Let's draw the tan first, then we'll sketch. So tan is always this. There is a vertical asymptote that's 90 and 270. You know, at 0, that's this 0 is 90. This is 180 is also 0. This is also 0. 270 is vertical asymptotes. So it will go this way. So that's how it will look like. Now, the reciprocal, so where is 0 now? Is 0 at 0, 1, 8, so there will be a vertical asymptote. So the other way around, to be a vertical asymptote. So see how it will look like. Cosine. Yes. Since at 0, okay, this is cot. That's cot. So at 0, there is a vertical asymptote. So where is tan not defined? It's not. Where is 0? Sorry. So 1 over 0, we know that cots but x is 1 over tan x, and it is 0. Tan is 0 at 0. We again 180 3C. So there will be a vertical asymptote. That's 180. What's your 3/6? So this is where sine 1 over, since tan 0 is 0, so it will be vertical asymptote at this basis. Why the other way around? This is now 90. Where it is not defined now. If you reciprocate, remember undefined means division by 0. So if you now reciprocate, where is 0, it will be defined, it will be 0. You get? If you reciprocate undefined, it's now 0. So that's why it's 90. If you check, tan is undefined. But vertical, so the other way around now. For cot, it will be 0. So y here is 270. Where there is a vertical asymptote at tan, it will be 0 at cot. So that's how we sketch the graph of 3 functions. So let's
First of all, we should know that the sine of any angle must be between 1 and -1. Yes. So the minimum is -1, maximum. So for this to be maximum, this should be positive. So making this to be negative, yes. Because if it's positive, the answer is negative. So we are saying that therefore sine 5 theta minus 10 degrees should be equal to -1, yes, which is sine 2/7. And from here we see that 5 theta will be 280 degrees, yes, making it the subject of formula. Therefore theta is 56. So that's the answer, option A. So thank you. First of all, we know that the cosine of any angle must be between -1 and 1. And also, for a fraction to be minimum, we should make the denominator very large, yes, while the numerator small. So what am I trying to say? So our concentration lies here. So we should use the maximum value of cosine, which is 1. So our answer is 12/3, which is 4. So option B. So that's the idea we use here. Thank you. Okay, welcome. We are given this table and we're asked to complete the table. Draw the graph of y equal to sine 2x and y equal to cos x. Use the graph to solve cos x minus sine 2x equal to 0. So the first thing we have to do is to complete the table, because if you are given a table of value, before we plot the graph, we need to complete the table. And how do you do it? We keep on substituting the values of x and y. So like I'll just do one. I will paste the complete table to save time. So like for the first table, when x is 30 degrees, you see that for y equal to sine 2 times 30, we have sine 60. And sine 60 is 0.8660, which is 0.9. We'll be using one decimal place. So that's the same way. If you now substitute y equal to cos 30, cos 30 and sine 60 are the same, so we have 0.9. So that's how we fill up the tables. So for the second one, okay, we'll fill for 150, we have sine. When x equal to 150, we have y equal to sine 2 times 150, which is sine 300. We know sine 300 is in fourth quadrant, which is minus sine 60. So we have minus 0.9. So for cos, y equal to cos 150, which is the same as minus cos 30, which is minus 0.9. So that's how we do and fill up the table. So no need of wasting time. Let me paste the complete table. We now move to graph. So that's our complete table. And from this table, you notice that, remember, we have two graphs here. That's the two values of y. So before we plot the graph, we need to know the maximum and the minimum. So to know that's the boundary for the graph. So from this, x is settled because s is the same in both. So we see that the y minimum is, from the table, is minus 1, and y maximum is 1. So with that, we've known that our graph will not exceed minus 1 and 1. So the maximum is 1 for y-axis and the minimum is minus 1. And for x, we have no negative values, so they are all positive values. So this will help us to locate the origin. So that's the essence of knowing the minimum and maximum. So we are getting our axis. So let me place this for x, for y. So we are getting our x and y axis. Okay. So as you can see, I think the origin will be better here. Let's check. If I count 1, 2, 3, 4. 1, 2, 3, 4. So the origin, the best place to locate the origin is here. So our origin is here. That's 0. Y, our x-axis. So that's our x-axis. Another name for x-axis is y equal to 0. Why this is y-axis, or x equal to 0. So we've located the origin, we've located the y and the x-axis. let's now locate that's the maximum. Let's put the points. So this is, if I count 1 2 3 1 2 3 4, so this is my 1, meaning here is 0.5. This is minus 0.5. This is minus 1. YX, we are moving in intervals of 30, so we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. So we've located that's the table for x, that's the values of x and the values of y. So let's now locate the points. So here, when x is 0, y is 0, I'll plot the first one and join before plotting the second one, so that won't make mistake. So when x is 0 for the first one, now let me just copy and paste the table where it will be. You will see it. Let's copy and paste. Okay. When x is 0, y is 0. So this is the origin. Let's use so that's it. That's the first point. When x is 30, y is 0.9, and we didn't get something here. Let's try. Remember, to get each of these grid line, we need to calculate it. Yes, each of these small minor grid lines, we've known the major one. We are going 0. Let's get each of them. And how do you do it? Each grid line for y is the interval we are moving over the total grid line. So that's interval. So we are moving in interval of, because the scale here, the scale is either 2 cm to 0.5 units. So the interval is 0.5. We are moving in 0.5 over the total grid line to that 0.5 is 10. So each of these will be 0.05. Yes. So each of these grid line is 0.05. So to locate a particular interval, that's the total, any total grid line now, then y will be interval over each of the grid line. So meaning that the values of y, each time I'm looking for it, if it's not seen visibly, I would divide that value by 0.05. That's it. Like if I want to locate 0.9 over 0.05, that gives me the total grid line. To get 0.9, I have to do 0.9 divided by 0.05 so that I can locate the total grid line starting from the origin. So if I do 0.9 divided by 0.05, I have 18. So I'll move up to 18. So we'll count. When x is 30, I'll move 18 grid lines up. So 5, 10, 15, 16, 17, 18. So that's my 0.9. So, and again, this is 60 is also 0.9. So is here. So in order to, okay, for 90 is 0, see 90 0. For 120 minus 0.9. So since 18 up is positive, 18 down will be negative. So 5, 10, 15, 5, 10, 15, 16, 17, 18. So for 180, for 150 is also that. So this is that. For 180, 0. That's it. For 210 is 0.9. That's positive. We'll go up 1, 2, 3. For 240, that's same positive. That's 1, 2, 3. For 270, 0. So we'll go down 0. For 300 is minus 0.9. So we'll go down 18 times. 1, 2, 3. For 330 is the same negative 0.9. 1, 2, 3. For 360 is 0. So we join. We'll take different ink. Okay, let's take green. So we're joining the point. That's it. That's it. We are moving. That's it. 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 And finally, so that's it. Let's change the color to green and let's make the line thick. So that's the first graph. We've done y equal to sine 2x. So let's label it. This is y equal to sine 2x. So let's draw for y equal to cos x. So we'll locate the points. Let's use blue. So when x is 0, y is 1. So 1. See, x is 0, y is 1. So that's the point. When it is 30, 0.9. So the same point as that. When it is 60, is 0.5. So 60, 0.5. That's the point. When it is 90, we have 0. That same point. When it is 120, we have minus 0.5. So 120 minus 0.5 is down here. It's visible. When it is 150, we have minus 0.9. So that same point here. When it is 180, we have minus 1. 180 minus 1, so we have this. So when it is 210, we have minus 0.9. 210 minus 0.9. Remember, 0.9 is 18 down here, 5, 10, 15, 16, 17, 8. So that's for 210. When it is 240 minus 0.5, 240 minus 0.5 is here. 270, that's same point. 300, 0.5. 300, 0.5 is up here. 330, 0.9. 330, 0.9 will be up. Let me move this to this side. Just move it after we'll continue. So when it is 330, we have 0.9. 330. 0.9 is 18 up, 5, 10, 15, 16, 17, 18. And when it is 360, we have 1. So 1 is here. So that's the point. So we'll finally join. Let's join the point. So we don't need this again. We don't need it. So let's join our points. So let's get our curve. So we are joining. We started from this, we'll move to this, we move to this, we move to that, we move to that, the next point, we move to the next point, we move to the next point, we move to that point, we move to that point, we move to that point. We move to that point, we move to that point, and finally to 360. So that's our curve. Maybe let's change the color. Let's change the thickness, and let's change the color. That's okay. So that's our second graph, which is y equal to cos x. Y equal to cos x. So let's label. We have, this is y equal to cos. So the next thing is to use it and solve the next question. They say use the graph and solve. We've done the first part, we've completed the table, we've done the graph. They say use it and solve cos x minus 2x equal to 0. Use the graph and solve cos x minus sine 2x equal to 0. So whenever you're asked to use a graph to solve a particular equation, what you have to do is to transform. So we're going to transform the given equation to look like the plotted function. So if you notice, the graph we plotted y equal to sine 2x and y equal to cos x. So we're going to transform this to look like these two graphs. So let's start. We have cos x minus sine 2x equal to 0. So moving this to the other side, we have cos x equal to sine 2x. And what's the meaning of this? This means the point of intersection maybe we have more than one point, so the points of intersection of the two graph function, that is y equal to cos x and y equal to sine 2x. So that should be the answer. So we'll go over to the graph and locate the point of intersection. So let me locate it. Let's use black. So you notice that they intersected here, so let's call it point A. So that's the solution. The x value, which is 30, that's the solution. B, that's the solution, which is C at point C, which is x equals to 150. So we have 2/7, so which is D. So the answer is now the points of intersection of these two graphs, which are 30, 90, 150. So which are 30, 90, 150, and finally 30, 90, 150, and 2/7. So these are the answers. So it's a very tricky question, but it's simple. Thank you.
At the point of intersection, sine x is equal to cos x. Yes, so at A and B, the two graphs are equal. So solving this, dividing both sides by cos, I have sine over cos, which is 1. So this is tan x equal to 1. So x is the arctan of 1. So what's the angle that the tan inverse is 1? So we have two angles. The first is 45 degrees, while the second is 225. Because third quadrant tan is positive. So from here you see that A. So you can see from here A is 45 degrees and B is 225. So you can see from here. So this is 225, this is 40. It's 225. C is now in y. C is the y value, which is cos 45 or sine 45. So it will give us root 2 over 2. YD is also cos 225 or sine 225. So both of them will give us minus root 2 over 2. So from here you can see our answers. A plus B is 225 plus 45, which is 2/7. YC minus D is root 2 over 2 minus root 2 over 2, which is root 2 over 2 plus root 2 over 2, which is root 2. So that's the answer. Thank you. Welcome back. We're on horizontal shifting of sine graph. It's possible you might be given a graph of a sine function and you're asked to find the function, the exact function. So the function will be within these 4 graphs. So the parent graph is the blue one. So this is a sine graph because it starts from the origin. Y cosine starts from the y-axis, that's the intercept, y-intercept. So this is y equal to a sine kx. So we can get the other three by shifting this blue graph either left or right. And also reflect it about the x-axis. So look at this y. This one in blue. Look at the red one. So if here is A, because here A, the absolute A, is called the amplitude. So if here is A, here is minus A. So this graph, the graph of the red function, so this one will be y equal to, as you can see, is now y equal to minus a sine kx. So do you see it? If you multiply by minus, you get the red graph. Again, we've gotten the two, this blue and red, remaining the other one. So if I decide to shift the blue graph to B units, so this graph, the equation will be y equals a sine k bracket x minus b. Yes. So, but if I shift it to the left, b unit, that's here is now minus b. This graph, this one will be y equal to a sine k bracket x plus b. So, and again, there's what we call the period. The period is the distance or the time, that's from here. So notice that this graph started from this and ends here. So it will still continue. So this is the end point. This is called one period. So from here to here is called a period. And it will represent it by, is denoted by t. And one period, t, is always 2 pi over k. And remember, k, where k must be a number greater than 0. K must be a positive number. Or if it's a negative number, we use a property. That's odd function property, that's sine negative k is now minus sine k. So we use that property. And also, since this is the one complete period is 2 pi over k. So I'm saying that here is 2 pi over k. Why this one? Remember, we shifted this one b unit to the right. So the point here will be 2 pi over k plus b. So that will be the one that it will end here. It started from b and it will end here. Why this one that shifted to the left will be 2 pi over k minus b. So that's it. So let's look at this question. So we're asked which of the following is the graph given. So we're asked which of the following is the graph given. So looking at this, you see that this is a sine graph, as you can see. But it's shifted 1 over pi to the right. So this is a sine graph because it started from the origin and shifted. So it's a sine graph. So if you shift back, if you shift 1 over pi to the left, we'll get back to the original. So this graph must be in form of y equals a sine k bracket x minus b. So our main aim is to find a, k, and b. So as you can see, from here our a is settled. So A is 2. That's it. So it's 2. So this is y equal to 2 sine. So let's get k. From here, how do you get k? We need to get the period. If you notice, one complete period is from here to here, to this point. But you got also another period ends here. So what do you notice? T is here, T is here. So we have 2 periods. So this graph covered 2 periods, starting from this. So what do you have to say? We calculate it by using the formula. That period, remember, we say that T is 2 pi over K. So, and we have 2T already. So 2T will be times 2, 4 pi over K. And let's get the value. So this is 1 over pi. Why this is 4 plus 1 over pi? So meaning that from there, these 2 periods, that's from here to here, will be 4. Yes. Since here is 1 over pi, and here is 4 plus 1 over pi. So the gap is 4. So this is equal to 4. So what do you have to say? K is pi, or K is pi. So our answer, and our shift, remember we shifted to the right. Yes, the original function will always start from the, but we moved 1 over pi. So our b, from here, b is 1 over pi. So let's now write, therefore the graph is now y equal to 2 sine k is pi, x minus b is 1 over pi. So anything like that. Okay, let's open up. So we have 2 sine pi times x is pi x, and pi times 1 over is minus 1. So this is the answer, y equal to 2 sine bracket pi x minus 1. So our answer is option B. So that is how we solve question that involves horizontal shifting of sine graph. Thank you. Welcome back. We're on horizontal shifting of sine graph. It's possible you might be given a graph of a sine function, and you're asked to find the function, the exact function. So the function will be within these 4 graphs. So the parent graph is the blue one. So this is a sine graph because it starts from the origin. Y cosine starts from the y-axis, that's the intercept, y-intercept. So this is y equal to a sine kx. So we can get the other 3 by shifting this blue graph either left or right. And also reflect it about the x-axis. So look at this, y. This one in blue. Look at the red one. So if here is A, because here A, the absolute A, is called the amplitude. So if here is A, here is minus A. So this graph, the graph of the red function, so this one will be y equal to, as you can see, it is now y equal to minus a sine kx. So do you see it? If you multiply by minus, you get the red graph. Again, we've gotten the 2, this blue and red, remaining the other one. So if I decide to shift the blue graph to B units, so this graph, the equation will be y equals a sine k bracket x minus b. Yes. So, but if I shift it to the left, b unit, that's here is now minus b. This graph, this one will be y equal to a sine k bracket x plus b. So, and again, there's what we call the period. The period is the distance or the time, that's from here. So notice that this graph started from this and ends here. So it will still continue. So this is the end point. This is called one period. So from here to here is called a period. And it will represent it by, is denoted by t. And one period, t, is always 2 pi over k. And remember, k, where k must be a number greater than 0. K must be a positive number. Or if it's a negative number, we use a property. That's odd function property. That's sine negative k is now minus sine k. So we use that property. And also, since this is the one complete period is 2 pi over k. So I'm saying that here is 2 pi over k. Why this one? Remember, we shifted this one b unit to the right. So the point here will be 2 pi over k plus b. So that will be the one that it will end here. It started from b and it will end here. Why this one that shifted to the left will be 2 pi over k minus b. So that's it. So let's look at this question. Okay, we are given this and we're asked to find the graph that is given. So this question requires two theorem or formulas. First of all, because looking at this is a sine graph. As you can see from what I just explained, you see that assuming this started from the origin, you see, assuming we started from the origin, it will go like this. You see, so meaning that the answer A. Remember, I told you the graph of, from what I said, the graph of sine is always y equal to minus a sine k x minus b. So if it is downward, it is minus a, but if it's up, it's plus a, from what I just explained. So the graph of this must be minus a sine, and from here you see that our a, as you can see, our minus a is 2, so we have minus 2 sine. So remaining k. And how do you get k? We get it using our period. So what is the period? As you can see, this graph started from here and it will end here before repeating. Or it will start from here and end here before repeating. So what do you notice? Here is also the period. One period. Or we'll say from here to here is one period. And as I've said, period t is always, I say that t is always 2 pi over k. Yes. And from here, how do you get from here? What's the distance from 0 to pi? So this is pi. Yes, period here is pi. Or if I do 2 pi minus pi. So what do you have to say? Our k is 2. So our k is 2. X minus. Shifting to the right is minus. Shifting to the left is plus. So that's why I have minus. And how many did we shift? Pi over. We shifted pi over 12 units. As you can see. Assuming it were to be the original graph, it will start from 0. Or it started from pi over 12. So that's the shift from here to here. That's the phase angle, which is pi over 12. So which of the option? Okay, there is nothing like that. Meaning that we need to employ second formula. So let's open up this first. We have minus 2 sine 2x minus pi over 6. So let's check the option to know which one gives us minus 2 sine. And how do you check it? We use what we call addition formula for sine. So there is one formula, addition formula, that says that sine A plus or minus B is always sine A cos B. So okay, I have minus. We'll use minus cos A sine B. So that's the formula we're going to use. The addition formula for sine A plus or minus B is that. So we'll check sine 2x, we are using minus pi over 6. So this is now sine A is 2x and B is pi over 6. We have minus here, so we use minus. So plus for plus, minus for minus. Cos 2x sine pi over 6. So let's check the value. From here, sine 2 cos pi over 6, which is cos 30. Cos 30 is, that is sine 2x times cos 30 is root 3 over 2 minus cos 2x sine 30 is half. So you see that this is equal to root 3 over 2 sine 2x minus half cos 2x. So plugging it back to this, so we have that sine 2x minus pi over 6 is equal to root 3 over 2 sine 2x minus half cos 2x. So factor. If we factor half, I have root 3 sine 2x minus cos 2x. So finally, remember, our main aim is to check if any of them is this. I have minus 2 sine that, so therefore minus 2 sine 2x minus pi over 6 will be equal to minus 2 times half, because we've gotten this as this. So which is this. So we have minus root 3 sine 2x plus cos 2x. So which of them is the answer? So that's the function. Y is equal to, maybe let's write cos 2x minus root 3 sine 2x. Let's check which one is the answer on A. Okay, welcome back. We have 4 different graphs here, but one of them is used in getting the remaining 3. So if you look at this one, the blue one is the parent graph. So there are some features. So we have here A, and we have here minus A. So this A is called, the absolute value of A is called the amplitude. And while the distance from here to where the graph ends is called the period. So we normally denote it with T. So P is the period is T, and T is always 2 pi over K, where K must be greater than 0, must be a positive number. So, and where is K? This is the parent graph. This is Y equal to A cos kx. So the coefficient of x is K. So you notice that to get this second graph, you shift the first one to B units. So if we call here B. So shifting this graph, the equation or the function will be, the graph will be, we now have y equal to a cos k bracket x minus b, because we shifted to the right. But if you shift to the left as this one, also shifting b units, so here it will be minus b. So the graph of this will be, this graph will be y equal to a cos k bracket x plus b. So if you shift to the left is minus b, to the right is plus b. And again, the period here, remember I told you the period is 2 pi, so here is 2 pi over k, meaning that here will be 2 pi over k plus b, since I shifted b units. Why here? If I shift to the left, it will be p, that's the point of intersection here, will be 2 pi over k minus b. So we've gotten the, okay, remaining this last one. The last one, that's the brown one. The equation is y equal to this minus a cos kx. So that's the equation of this last one. As you can see, y is minus because if you multiply by any positive, it becomes negative. So the ones above the x-axis will be below, since it's minus. While the ones below will be above, like this. The values of y here will be positive. So let's now solve the equation to justify that. But before this question, in case if you have k to be negative, so if k is less than 0, remember that cos of negative value is the same thing as the positive, as you neglect it. So we use that property if we notice that k is negative. So let's solve this question. Okay, look at this. As you can see, this graph is a cosine graph, but it's shifted pi over 4. So that's the shift, meaning that this is off, because I have a positive, but is here. But if it started from here, we have the negative. So that's it. So these two are off, remaining these two. Let's check something. I have coefficient of x here, that's k to be negative. So I need to write this as 3 cos. We can bring out this negative 2. This is x plus pi over 2. Well, remember I told you that cosine of negative angle is neglected. That negative side is neglected. So this is now 3 cos 2 bracket x plus pi over 4. Why this is, to bring out the negative sign, I have x minus pi over 2. So which is 3 cos 2 bracket x minus pi. So as you can see, this is shifting to the right. So you see that this is off, but this is left, so it's off. You see it? I shifted to the right, so you always be negative. So without even solving further, D is the answer. But let's finish up. Remember, I told you the general function for cosine shifting. Cosine graph is A cos K bracket x minus B. And from here, let's get our K. We don't know the K. We can get the K using the period. From here, you see that the period from, that's this gap from here to here is the period. T is, what's the difference? That's 5 pi over 4 minus pi over 4 is pi. So our period here is pi. But I told you that period T is always 2 pi over K. And from the diagram is equal to pi. So what do you have to say? K is 2. So as you can see, from this, K is 2. So we have A. Our A is 3. Are you seeing it? 3. So I have 3 cos 2 x minus, and our B, remember, from here B is pi over, it is pi over 4. Okay, if you factor it, okay, pi over 4. This is 4. So our answer is option D, which is correct. So that's our answer.